Hi, I'm Chem's best friend. Please like and subscribe to my channel. If you would like to know how to contact me, the information is on the bottom of your screen. So let's get started. In the previous video, we learned about significant digits, and we introduced how to do significant calculations with significant digits. There was one rule for multiplication and division, and second rule for addition and subtraction. In chemistry, we will really use the rule for multiplication and division a lot. So let's do some calculations using our correct number of sig figs, significant figures, and let's learn how to do dimensional analysis. So dimensional analysis, when you think of it, it's probably just converting units from one to another. And you're probably thinking, why does my chemistry teacher care how many centimeters are in a mile? Well, the answer is your chemistry teacher does not care how many centimeters are in a mile. This is a way to teach you a method. It's to teach you a method that you will use later when we will be counting atoms. Okay? So it's something to grasp easier for you. Once you know the method, then you will get a new concept of how you're going to use dimensional analysis to count atoms. Okay, let's get started. Let's go to my screen. So here is our first problem. Here we have a road, and let's say I walked 5.25 miles today. It was a long walk. The question is, how many centimeters did I walk? So we're changing units of length, and here in purple, I'm going to give you a little bit of conversion factors. And many times, conversion factors within a metric system, you probably will have to know. And conversion factors between the English and metric system probably be given to you. So here is some information, and let's plan. Well, first, I would like to know, let's look at the middle conversion factor. It says it's the only one that has miles, and it tells me how many kilometers. So I think the plan would be, if we start with miles, then we will go to kilometers, and then, so this is what I'm going to use. And there's another conversion factor right below that has kilometers and meters. See it? And then on top, I have meters and centimeters. So if I go to miles, to kilometers, then to meters, and then to centimeters. That's my plan. So let's do that. So we're going to start. So we start with what we know, 5.25 miles was walked. And you can think of this as over 1. Everything usually would be over 1. Times, okay, let's think about this. I'm going to change it to kilometers. How many kilometers in a mile? Well, I look at this and I have 1.61 kilometers are in 1 mile. Now, this is what's important here. I have to put things in such a way that my units cancel. Look, miles here is on top, and I have to have miles on the bottom, so my units cancel. Do you see it? So now I'm going to keep going, because there's no need to hit the equal sign on my calculator now. Let's keep going. Well, there is 1,000 meters in a kilometer. What goes on top? What goes on the bottom? If I have kilometers here on top, I have to have kilometers here on the bottom, so to cancel it out. So let's put there is 1,000 meters in 1 kilometer. Times, let's keep going. What else do I have? Well, there is 100 centimeters in 1 meter. Let's make sure all my units cancel out. I have kilometers on top, kilometers on the bottom, they cancel out. Meters on top, meters on the bottom, cancel out, and I'm left with centimeters on top. There you go. If I plug this number into a calculator, I get this answer. 8, 4, 5, 2, 5, 0 centimeters. So 845,250 centimeters. That's what the calculator says. Is this the answer? Well, now let's think about our sig figs, right? So if I walked 5.25 centimeters, remember this here 5, that's my estimated digit. This is where my uncertainty comes. It is significant. So I have 3 sig figs. I have 3 sig figs here multiplied by, well, this is also 3 sig figs. 1.61 is 3 sig figs. It's actually, if you keep going, it would be 1.609 kilometers per mile. And I can keep going, but here I chose to give you with a conversion factor with 3 sig figs. This one, 1,000 meters in a kilometer versus exactly 1,000 meters in a kilometer. Remember, that means it has an infinite number of sig figs. And the same here. There is exactly 100 kilometers, so it's infinite. So remember our rule for multiplication and division? Our answer has to have the least amount of sig figs. So 3 sig figs and 3 sig figs, infinite, infinite. The answer needs to have 3 sig figs. So let's go here. It's going to have an 8, 4, 5. And I look, and the digit after 5 is 2. So this becomes 0, 0, 0 centimeters. Yes? So 845,000 centimeters. I can also put this in scientific notation. So I can squeeze this here. So I can say there is 8.45 times 10 to the 5th centimeters. And here it's great because the scientific notation tells me exactly that I have 3 sig figs. How did you do? Is this making sense? We're going to cancel the units, yes? Okay, let's go. Another question. So here is, we'll be changing units of volume. Let's say we have a glass of nice iced tea. We're going to drink 9.5 ounces of it. And the question is, how many liters did I drink? How many liters? Well, let's come up with a plan. Let's look at the conversion factors that we have. And we are given ounces, and here is the conversion factors with ounces. So it seems like if I go from ounces to milliliters, then I have milliliters here and I can go to liters, right? So my plan will be to take the ounces, change it to milliliters, and then change it to liters. That's my plan. So let's start. So I have 9.5 ounces. Now remember, I can say it's like over 1 times, I'm going to say, okay, so now, do ounces go on top or on the bottom? What do I put? Do I say 1 ounce over 29.57 milliliters? Or do I say 29.57 milliliters over 1 ounce? Where here, remember, it's over 1. Ounces on top. Ounces here on top. I need to have ounce right here on the bottom for it to cancel out, yes? So let's do it. So we're going to say it's 29.57 milliliters per 1 fluid ounce times, and then we're going to say, well, 1 liter on top, 1,000 milliliters on the bottom. Let's make sure ounces cancel out, milliliters cancel out. I'm left with liters. And I plug this into my calculator and I get this answer, 0.280915 liters. Okay, let's worry about sig figs. So how many do I have here? 9.5. It could be 9.4. It could be 9.6. So I have 2 sig figs here too. Here, I gave you a conversion factor with 4 sig figs. And this one is a definition where it's infinite. Which one is the smallest number? 2. Right? So my answer has to have 2 sig figs. So this 0 is the placeholder 0, not significant. I need to have 2 and 8. I look at the 0 behind. So my answer will be then 0.28 liters with 2 sig figs as my answer. How are you doing? Are you ready to make it a little bit harder? Let's go. I'm going to make things a little harder right now. So here is our problem. Here is Usain Bolt. He has world record for a run of 100-meter run. He ran 100 meters in 9.58 seconds. That's amazing. Let's pretend Usain Bolt is looking for a new coach and I volunteered. The thing is, I cannot run as fast as he does. So my plan is I will be riding a golf cart next to him. But the golf cart is made in USA and the speedometer is in miles per hour. So my question is, when Usain Bolt is running 100 meters in 9.58 seconds, and I'm going to be riding my golf cart next to him, how many miles per hour will my speedometer tell me that I'm driving? How fast will I be driving? Let's do it. Well, this problem is a little bit harder because we have to change 2 units. We have to change a unit of length from meters to miles, and we have to change a unit of time from seconds to hours. Which one do you want to do first? Pick one and you do it one at a time. I'm going to change length first and then time. And my plan will be to first change meters to kilometers, and then kilometers to miles, and then seconds. I'm going to change seconds to minutes, and then to hours. That's my plan. So let's do it. So we have 100 meters. Now this is no longer over 1, and that's okay. In 9.58 seconds, okay, units of length, remember. So I'm going to say there is 1 kilometer has 1,000 meters, and then 1 mile has 1.61 kilometers. Let's take a little pause here. So my meters cancel out, my kilometers cancel out, and I'm left with miles, which is great. But I also have right here these seconds. If I just say equals and calculate it, I'm going to have miles per second. I don't want miles per second. I need miles per hour. So I'm going to keep going. So now look, second is on the bottom. So how many seconds in a minute? So I have 60 seconds per 1 minute. And I have 60 minutes in 1 hour. Let's quickly make sure. So I have seconds on the bottom, seconds on top, minutes on the bottom, minutes on top, and I have hours left on the bottom that doesn't count, that doesn't cancel with anything. This is great. If I plug this number in a calculator, I'm going to get something that looks like this. 23.340555162 miles per hour. Okay, so let's figure out how many correct sig figs our answer should have. This one, we have 100 meters. We can assume that it actually is 100.0 or 100.00, but 9.58, that's the estimated. So we have 3 sig figs here. This right here, the next one, it's a definition, infinite number of sig figs. Right here, we also have 3. This one definition of time, one infinite and infinite right here. So the least number of sig figs is 3. So our answer should have 3 sig figs. So Usain Bolt runs at 23.3 miles per hour. Wow, that's fast. Okay, are you ready to go a tiny bit harder? Here is the problem. Here is a challenge problem. I would love to set up an aquarium at home. And here is my tank, and it is 18 inches long, 6.50 inches wide, and 11.3 inches high. And the question is, when I pour in water, how many liters of water will I pour into this tank? Oh, a little bit harder. So there is 2 ways of doing this problem. The first problem would be to take these measurements of inches and change it to centimeters. Change this to centimeters, every one of them first. And then you can see we have and multiply them through. You will already then get a volume in centimeters cubed. You can change it to milliliters. And from milliliters, you can change it to liters. And here's how you change from inches to centimeters. Here's your conversion factor. So that would be an easier way. That's great, but I'm going to show you a little bit harder way how you're going to do this. So I would actually like to quickly say, okay, my volume, remember, definition of volume equals length times width times height. And I'm going to use my inches. So if I'm going to do 18.0 inches times 6.50 inches times 11.3 inches, I'm going to multiply it through. I'm going to have 1,322.1 inches cubed. And you say sig figs. Hold on, let's leave sig figs last. We will worry about sig figs last. So I'm going to keep this number in my calculator. So this is my volume in inches cubed, right? So let's do this. So I have 1,322.1 inches cubed. And now let's change it to centimeters cubed. Okay, so I do know that there is 2.54 centimeters in 1 inch. Then I need to cube it. Okay, I need to cube this. Now, here is the thing. When I cube this, I need to take and I need to cube the number, cube the unit. I need to cube the number, cube the unit. And you say, why? Here is why. Here is a little thought process on the side. If I have a little cube that's 1 inches cubed, okay? If this is 1 inch on this side, 1 inch here, and 1 inch here, this means that this is also 2.54 centimeters. And this is 2.54 centimeters. And this is 2.54 centimeters. So if I want to find the volume of this cube, I'm going to say 1 inch times 1 inch times 1 inch, which is 1 inch cubed, or I'm going to say 2.54 centimeters times 2.54 centimeters times 2.54 centimeters. So I need to cube the number, cube the unit. Okay. So remember, that's the important part here. Then I'm going to say, okay, if I'm going to do this, I'm going to say 1 milliliter then is 1 centimeter cubed. Yes, and then 1 liter is 1,000 milliliters. Is this making sense? You following me? So if we do this, you are going to get something like this. You're going to get 21.66533.731 liters. Whew. What do we put on a test? or on your homework? Well, let's think about this. These numbers, units of length given, all had how many sig figs? 3 sig figs. Yes, all of them had 3 sig figs. That means this answer then should have been 3 sig figs. Let's keep this here. So we have 3 sig figs. This is really interesting. This is infinite number of sig figs. This is a weird conversion factor between English and metric that actually is exact. And this is, again, definition infinite, and this is infinite. So our answer should have 3 sig figs. So I'm going to say, okay, here's 1, 2, 3, but I look behind to see what do I do. And my answer will be 21.7 liters. I'm going to use 21.7 liters of water to fill in my aquarium tank. So how did you do? We went through 4 problems. The first 2 were pretty simple, just changing one type of unit, either units of length or units of volume. Then we went and we changed 2 units in one problem. And then we went and we dealt with dimension analysis using volume. Remember, you got to cube the number, cube the unit. Okay? I hope you practice a little bit and get better at it. Thanks for watching, and see you next time.